let's take a look at our last problem for today. So it says we have an equilateral triangle that has a perimeter of 21 meters, and the area is multiplied by 1/2, and we want to know what happens to the side length. Okay, so let's start this problem by looking at a triangle, and let's just say instead of having a side length of, or a perimeter of 21 meters, let's just say it has a side length of s. Right, so each of these side lengths are congruent, right, to the same measure, okay? And we know that with an equilateral triangle, it's also equiangular, right? Meaning that all of the angles on the inside are also going to be the same, right? So that means that each of these are 60 degrees, right? Because there's 180 degrees in a triangle, right? So if I bisect this angle right here, okay, that would mean that, first of all, this is a 90-degree angle, okay? It would also mean that this angle right here is 30 degrees, okay? And it also would bisect this opposite side, meaning that this length right here is 1/2 times s, okay, or 1/2 of whatever that side length is, okay? Now, what we have to understand here is that we do have a special right triangle, so I'm going to outline this triangle in red here. Okay, we do have a special right triangle, okay, so our ratios are going to be the side opposite of the 30 has a ratio of 1, okay, our side opposite of the 60 is going to be radical 3, okay, and our side opposite of the 90 is going to be 2, okay. Well, let's first of all think like, okay, what do we actually want here, right? We want an expression that represents the area for the side length, or for an equilateral triangle with any side length. Right, so our area is going to be equal to 1/2 times base times height, okay? Well, we know what the base is, we know it's s, right? So our area is going to be equal to 1/2 times s times whatever our height is of this triangle. Now remember, our height is not radical 3, right? That's the ratio, okay, of that particular side length, given the ratio of, the opposite side of the 30 degree, okay? And so what I can do now is I'm just going to set up a simple ratio, okay? And I'm going to set maybe I'm going to do short leg to long leg. So I'm going to say 1:2 radical 3 as, and I know my actual length of my short side we're going to call 1/2 s. And we're going to compare that to our height of this triangle is just going to be, I'll just call it x here. Right? So really when I use the cross products property, I'll find that x equals 1/2 s times radical 3. Or in other words, that's going to be radical 3 over 2s, right? So this is our expression that actually represents the height of our triangle. And so I'm going to go ahead and put that right in here, radical 3 over 2s. Okay, and now I'm just going to simplify my expression for area, or my equation for area. So I'm going to say my area equals 1 times radical 3 is radical 3, 2 times 2 is 4, and we're going to call this s squared. Okay, so this is definitely going to help us solve our problem. All right, now we want to take a look at kind of like our actual triangle, right? So it says this equilateral triangle has a perimeter of 21 meters, right? So if we were to draw this particular equilateral triangle, just a small little picture of it, okay, we think, well, if all these sides are the same and the perimeter is 21, if we divide that by 3, each side length has a length of 7 meters. Okay, and so at this point we want to write an equation, okay, that's basically going to give us the area of this particular triangle. So we're going to use our formula from the last part here, right? So we're going to use this, and we're going to say, well, then our area is going to be equal to radical 3 over 4 times s, which is 7 squared, which then is going to give us 49 radical 3 over 4. Okay, so that would be the area of this particular triangle that has, or this equilateral triangle that has a side length of 7 meters. Okay, well now it's saying, well, if the area is multiplied by 1/2, okay, well, so the area is going to be basically multiplied by 1/2, or half of what it was before. All right, and so now what we have to do is really just kind of simplify this, right? So the area of this new triangle looks like it's going to be 49 times radical 3 over 8, right? Because we just kind of multiply these fractions. Okay. Well, now what we're concerned with is saying, okay, well, what actually happened to our side length now? right? We know that the new area is different. It's half of what it was before, but how is the side length compared to what it was before? Okay, so what we're actually going to do now is we're going to take this right here, okay, this expression for the area, and we're going to take our area of our new triangle here, and we're just going to kind of substitute radical 3 over 4 s squared for a. And so what I'm going to write down here is I'm just going to say that rad 3 over 4 s squared is going to be equal to 49 radical 3 over 8. Okay, and now I'm trying to isolate for s squared. So it looks like I have to multiply by the reciprocal of this fraction here. So 4 over radical 3. I'll do that to each side. Okay, I know that these are going to multiply to 1, so those will reduce. Okay, I know that rad 3 over rad 3 will divide to 1. Okay, and basically what I'll end up with here is that s squared is going to be equal to, again, this will reduce to 1 over 2. And so basically what I end up with is that s squared is equal to 49 over 2. Okay, and if I want to actually solve for s here, what I'm going to do is take the square root of both sides. Okay, and so when I do this, I end up getting now s is going to be equal to 7 over radical 2. Okay, well, again, I have to rationalize the denominator here. I cannot keep a radical in the denominator, so I will multiply both the top and the bottom by radical 2. And I find out that my side length is going to be equal to 7 radical 2 over 2. Okay, and so that is my answer for my new side length. Okay, and so if we look back at the original question, right, it asks us what happened to the side length. Okay, well, I'm just going to write down kind of a little star over here. I'm just going to say original side length was 7. The new side length is 7 rad 2 over 2. So the side length was multiplied by radical 2 over 2. Okay, and so from there, we are now just done with the problem, right? So basically, if the area was cut in half, the side length is going to be multiplied by radical 2 over 2.